Class 11th, Subject Physics, 11th chapter, Electrostatics. From the chapter, let us see numericals from exercise. Numericals from exercise. Let us see some of the numericals from the chapter. Let us consider first numerical, which is given as two small spheres 18 centimeter apart have equal negative charges and repel each other with the force of 6 into 10 raised to minus 8 Newton. Find the total charge on both spheres. And therefore, for this numerical number 1, given data is r is equal to 18 centimeter, that is the separation between the two spheres, which will be written as 18 into 10 raised to minus 2 meter. Then force acting is equal to F, that is 6 into 10 raised to minus 8 Newton. The value of 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 Newton meter square per Coulomb square. Both the charges Q1 and Q2 are the same, let it be equal to Q. So both these spheres are having the charges Q present on them, and at last we have to find out the total charge, that is value of 2Q we need. And therefore, for this, the electrostatic force between the two charges is given by the formula F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square. But here Q1 is equal to Q2 and that is taken as Q. Therefore, F will be equal to 1 upon 4 pi epsilon 0 Q square by R square. And therefore, from this we can write Q square equal to F R square into 4 pi epsilon 0. Q square equal to F R square into 4 pi epsilon 0. Putting the values, we will get Q square equal to 6 into 10 raised to minus 8 into 18 into 10 raised to minus 2 its square into 1 upon 9 into 10 raised to 9. Because 1 upon 4 pi epsilon 0 is having its value 9 into 10 raised to 9, and therefore 4 pi epsilon 0 will be 1 upon 9 into 10 raised to 9. So simplifying it, we will get 6 into 324 into 10 raised to minus 12 upon 9 into 10 raised to 9. And therefore Q square comes out to be 21.6 into 10 raised to minus 20. 21.6 into 10 raised to minus 20, that is Q square. To find Q, we can write it as Q is equal to square root of this. And therefore its square root comes out to be Q equal to 4.648 into 10 raised to minus 10. As the charge is negative, therefore it is taken as minus 4.648 into 10 raised to minus 10. So this will be the charge Q which is present on each sphere, and therefore total charge which is present on both sphere will be equal to 2Q, which comes out to be minus 9.296 into 10 raised to minus 10 Coulomb. So this will be the total charge present on these two spheres. Now let us go for numerical number 2, which is stated as a charge plus Q exerts a force of magnitude 0.2 Newton on another charge minus 2Q if they are separated by 25 centimeter. Determine the value of Q. So here there are two charges, plus Q charge and minus 2Q charge, which are separated by distance 25 centimeter, and therefore given data is F is equal to 0.2 Newton. Distance of separation R is equal to 25 centimeter, that is 0.25 meter. Then first charge Q1 is equal to plus Q. Second charge Q2 is equal to minus 2Q. Again 1 upon 4 pi epsilon 0 equal to 9 into 10 raised to 9 Newton meter square per Coulomb square, and we have to find out value of Q. And therefore for that, Again we will use the force, that is electrostatic force. F is equal to 1 upon 4 pi epsilon 0 q1 q2 by r square. So that force will be written as F is equal to 1 upon 4 pi epsilon 0, putting the values of q1 and q2 as q into minus 2q upon r square. Q is q1, minus 2q is q2, and therefore we will get that force is equal to 1 upon 4 pi epsilon 0 minus 2q square by r square. 1 upon 4 pi epsilon 0 minus 2q square by r square, and therefore simplifying it we can write q square will be equal to f r square into 4 pi epsilon upon minus 2. So we have written here formula for q square, that is q square equal to f r square into 4 pi epsilon 0 upon minus 2. Putting the values we will get 0.2 into 0.25 square divided by 9 into 10 raised to 9 into minus 2, which comes out to be 0.1 into 0.25 square upon 9 into 10 raised to 9. And therefore q square will be equal to 62.5 upon 9 into 10 raised to minus 12. 62.5 upon 9 into 10 raised to minus 12, and therefore as it is q square we can find q by taking square root. So q will be equal to square root of 62.5 upon 3 into 10 raised to minus 6. 62.5 under root it will be, and divided by 3 into 10 raised to minus 6, which comes out to be 7.906 upon 3 into 10 raised to minus 6, and therefore that q will be written as 2.635 into 10 raised to minus 6 coulomb. 2.635 into 10 raised to minus 6 coulomb, which comes out to be 2.635 microcoulomb. 2.635 microcoulomb, and this will be the required charge. Now let us go for next numerical, that is numerical number 7 from the exercise, which is given as 3 equal charges of 10 into 10 raised to minus 8 coulomb respectively, each located at the corners of a right angled triangle whose sides are 15 centimeter, 20 centimeter and 25 centimeter respectively. Find the force exerted on the charge located at 90-degree angle. And therefore let us consider here the given data. q1 is equal to q2 is equal to q3 will be equal to 10 into 10 raised to minus 8 coulomb. So all the charges are having their magnitude same, that is 10 into 10 raised to minus 8 coulomb. Then 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 Newton meter square per coulomb square. And then we will have to find out the force acting on the charge which is located at point B. That is, for that purpose we have considered this right angle triangle ABC. At all these points A, B, C, charge Q, which is having its value 10 into 10 raised to minus 8 coulomb, is situated. The sides are taken as 0.15 meter, that is 15 centimeter, then 0.20 meter, that is 20 centimeter, and 0.25 meter, that is 25 centimeter, are the three sides of this right angle triangle. Then the charge which is located at this point B will be acted upon the forces exerted by the charges located at A and C. So that force we will have to calculate, that is FB. And therefore separately we can find first the force acting by the charge Q located at point A on this charge located at B. Then secondly, the force due to the charge located at point C acting on the charge located at point B. And therefore let F1 and F2 be these two forces due to the charges situated at point A and C. and therefore we can write for F1 on Q at B due to Q at A, that is force acting on the charge at B due to the force due to the charge which is placed at point A, that is F1 will be equal to, in magnitude and direction, 1 upon 4 pi epsilon 0 Q square upon AB square J cap. Here this triangle is taken in xy plane, and therefore unit vectors along x and y, that is I and j, we will consider, and therefore F1 is equal to 1 upon 4 pi epsilon 0 Q square upon AB square J cap. Therefore F1 will be written as 9 into 10 raised to 9 into Q square, that is 100 into 10 raised to minus 16 divided by AB square, that is 2.25 into 10 raised to minus 2, 2.25 into 10 raised to minus 2 J cap, which comes out to be 4 into 10 raised to minus 3 J cap, 4 into 10 raised to minus 3 J cap Newton. Similarly, the force acting due to the charge at C on this charge at B we can calculate. Let that force be F2, and therefore for F2 on Q at B due to Q at C will be given as F2 is equal to 1 upon 4 pi epsilon 0 Q square upon BC square I cap, and therefore we can write F2 is equal to 9 into 10 raised to 9 into 100 into 10 raised to minus 16 upon 4 into 10 raised to minus 2, 4 into 10 raised to minus 2, that is BC square, into I cap, which comes out to be 2.25 into 10 raised to minus 3 I cap, 2.25 into 10 raised to minus 3 I cap Newton. So these are the two forces which are acting on that charge placed at point B, and therefore the total force or the net force acting on Q, the net force acting on Q at B will be the factor sum of these two forces F1 and F2, and therefore F will be equal to F1 plus F2, which will be equal to 4 into 10 raised to minus 3 joule J cap plus 2.25 into 10 raised to minus 3 I cap. So this is the term of I, this is the term of J, and we know that in case of vectors, the magnitude of the vector is given by square root of ax square plus ay square plus az square, like this, so that it will be ax, it will be ay, and then only two terms are there. Therefore we can write magnitude of force F will be equal to, this total force is F1 plus F2, that is equal to 4 into 10 raised to minus 3 J cap plus 2.25 into 10 raised to minus 3 I cap, and therefore magnitude of force will be equal to square root of this ax square plus ay square, that is 2.25 square plus 4 square under root into 10 raised to minus 3. Therefore F will be equal to square root of this 2.25 will be written as 9 by 4 and its square plus 4 square, that is 16 into 10 raised to minus 3. That will be equal to square root of 81 upon 16 plus 16 into 10 raised to minus 3, which will be written as F is equal to square root of 333 upon 4 into 10 raised to minus 3. Square root of this comes out to be 18.36, and it will be divided by 4 into 10 raised to minus 3, and therefore we will get F is equal to 4.59 into 10 raised to minus 3 Newton, 4.59 into 10 raised to minus 3 Newton, which is the required force. Then we will go for next numerical, that is numerical number 8, which is given as a potential difference of 5000 volt is applied between two parallel plates 5 cm apart. A small oil drop 5 cm apart, a small oil drop having a charge of 9.6 into 10 raised to minus 19, 9.6 into 10 raised to minus 19 coulomb falls between the plates Find electric field intensity between the plates and force on the oil drop. And therefore, for this numerical number 8, given data is potential V is 5000 volt, distance of separation between the plates D is equal to 5 centimeter, that is equal to 5 into 10 raised to minus 2 meter. Then charge Q is given 9.6 into 10 raised to minus 19 coulomb. And we have to find out electric intensity, that is electric field E, and the force acting on the oil drop F. And therefore, we know the formula for electric field intensity. Electric field intensity E is equal to V by D. That is electric field intensity is equal to potential gradient, that is E is equal to V by D. Therefore, 5000 upon 5 into 10 raised to minus 2. 5000 upon 5 into 10 raised to minus 2, which comes out to be 10 raised to 3 into 10 raised to 2, which is 10 raised to 5 Newton per coulomb. This will be the required electric field intensity. Now, the electrostatic force acting on the drop. The electrostatic force acting on the drop will be F is equal to QE. F is equal to QE, that is charge into electric field, that will be equal to 9.6 into 10 raised to minus 19 into 10 raised to 5. Then that force comes out to be 9.6 into 10 raised to minus 14 Newton. 9.6 into 10 raised to minus 14 Newton. This will be the required force which is acting on that oil drop. And then let us go for next numerical, that is numerical number 9, which is given as calculate the electric field due to a charge of minus 8 into 10 raised to minus 8 coulomb at a distance of 5 centimeter from it. And therefore, for this numerical, given data is charge Q is equal to minus 8 into 10 raised to minus 8 coulomb, that is the negative charge. Then R is equal to 5 centimeter. R is equal to 5 centimeter, which will be written as 5 into 10 raised to minus 2 meter. Then 1 upon 4 pi epsilon 0 equal to 9 into 10 raised to 9 Newton meter square per coulomb square. And we have to find out electric field intensity E, that is electric field. Now, electric field E is given by the formula 1 upon 4 pi epsilon 0 Q by R. Electric field intensity at any point due to the charge is given by the formula 1 upon 4 pi epsilon 0 Q by R. And therefore, E will be equal to 9 into 10 raised to 9 into minus 8 into 10 raised to minus 8 divided by 5 into 10 raised to minus 2. 5 into 10 raised to minus 2. Here only the magnitude is considered, and therefore E will be equal to 14.4 into 10 raised to 3. 14.4 into 10 raised to 3, and therefore that electric field E will be equal to 1.44 into 10 raised to 4. 1.44 into 10 raised to 4 Newton per coulomb. This will be the required electric field due to that given charge.